Hello everyone, Hal here. In this video I want to go through the solution to task 3 in the Q-Sharp practice set. In this task we are given the problem of implementing an operation called EPR_n, which takes as an argument an array of qubits, puts those qubits into the n-qubit Bell state, performs a measurement on those qubits, and returns the result of that measurement. So the first thing we need to do to implement this operation is to define the operation. So we'll create our operation, taking the argument of one qubit array of arbitrary length and returning an equal length result array. So the first step to generating the n-qubit Bell state is to take the first qubit in the array and put it in a superposition by applying a Hadamard gate. This maps us from the state 0 to the state plus. After that, we need to perform a controlled NOT operation between the first qubit and every other qubit in the array. So to do this, we use a for loop starting from index 1 up into the last index of QS, which we can access through the length function. Okay. Then here we will apply our controlled NOT conditioned on qubit 1, operating on the ith qubit. Okay. So this code is sufficient to put all of our qubits into the n-qubit Bell state. For the next part of our operation, we need to perform a measurement on every qubit in our array and return the result of all of those measurements. In order to do this, the first thing we need to declare is an array in which we can store the results of every measurement. So we'll declare a mutable array, we'll call it result. It is a new result array of length equal to the number of qubits we have. Now we need to loop through the qubit array, perform a measurement on each qubit, and store that in result. So we'll start index I, starting from index 0, going up to length of QS minus 1. And then we will write code to store the result of every measurement at the ith index. And then we will reset the qubit at the ith index. You're probably wondering what the meaning of this line is. I'm not going to go into detail here, but I will put a blog post in the description of this video which dives more into arrays in Q-Sharp. All you need to understand in this, though, is that right here we are specifying the index, and here we're specifying the value. So the way to interpret this line is we're setting the ith index in result equal to the measurement of the ith qubit in our array. From here, we just need to return the result array to complete our operation. In actuality, this is an inefficient way to go about implementing this kind of operation. The process of measuring every qubit in an array is so common that there are simpler methods to go about it. In fact, we can actually reduce everything we just wrote to one line using a couple of built-in functions. So if we use for each and m reset z, we will produce an equivalent result. What this line of code does is it applies the m reset z operation on every qubit in QS and stores the result of each of those m reset z operations in an array, which is then what our function returns. So in reality, it would be much better to just use this line. However, both were valid.